Hello guys, good evening. Let's see for a couple of minutes and look at for others and then we start. Okay, let's start it then. If they will join, I think they will join. Okay, now I think hope you guys have noted down the fixed and moment section. Okay, so yesterday, last class we discussed about the methods to solve the intermediate structures, and then I have told you to note it down some of the fixed and moments for UDL, point load and UVL loading and for concentrated moments, as they will be very much useful. So let us, before going to start the slope deflection method, if we are talking about the displacement methods, so as we know, what is the first step? The first step we have to identify what is the kinematic indeterminacy. And in the second step, or we have to write it down, or you have to find out the fixed end moments, and after that you have to obtain the final end moments by using any other method. Here, whatever the method that you are going to find out, at the end of the day, you will end up with this final end moments. And by using these final end moments, we will solve the support reactions. After that, we can draw the shear force diagram, and after that, we can draw the bending moment diagram. And even after that, if you are interested, then you can find out displacements at any point. Displacements are rotations. So all these four parameters, either support reactions, shear force diagram, bending moment diagram, or displacements or rotations at any point, they will be find it out only after the final end moments only. So either you do slope deflection method, or you do moment distribution method, or you do Han's method. The first you will obtain is final end moments, and then we will solve the remaining thing. And if you ask me about the stiffness method, there we will directly find out the reactions that are required, that we will see in the coming classes. So as of now, as I'm telling you, so this is what the very important final end moments. So the whatever the answer you are going to find out, that is going to depending upon the final end moments only. Now let us come back to classical slope deflection method. So if you are in earlier days, if you're talking about state PSC exams, then there the people might ask who proposed this method. There are questions that have come like this also, but nowadays the people are not asking these type of questions, as you know how the competition has increased, and that's why we are not going into who invented this method in which year. All those kinds are not required, right? So the first important that you guys have to understand is that you have to remember the, I'm not going to doing the derivation as it is not much required, or they are not going to, even in the exam, it's not going to help you anything. It's not like our regular university exam, there you have to derive something. No. If you can remember this final end equation and if you can understand, that is well enough and we can solve any problem. So as you guys remember, fixed end moments, let us say if I'm talking about a member, let us say there are supports in between. Let us say these are continuous, and let us say this is member A and this is member B. So if you want to find out moment at A towards B, that will be equal to, first you have to find out fixed end moments at A towards B plus 2EI by L times, always remember if I'm talking about the beam AB, if I talk about AB, A will comes the near end and B will be represented as a far end. Similarly, if I am talking about BA, that means I am finding the moment at B towards the point A. So what is my near end? My near end will be represented as a B, and far end will be represented as A. So at whatever the point you are finding, that will be treated as a near it, and towards which span you are finding, that's gonna treat it as a far end. So 2EI by L times 2 times the near end rotation. What is the near end if you are talking about AB? A. 2 times the near end rotation, theta A, plus far end rotation. Far end point here it is B. So theta B minus 3 delta by L. So if you can remember and if you can understand each of the term, then nothing complicated about this method. So here this delta represents the sinking of supports. If there is any sinking of support, then that we will accounted here. Well, because if there is any sinking of support, obviously unnecessary rotations or movements will develop in the beam. After this, the first point that should strike your mind is that what is the sign convention that I have to follow? So if somebody asks me about what is the sign convention that I follow, then you know what I will do. As I'm telling you previous also, the direction matters. So either you can consider the sign convention based on the clockwise, or you can consider the sign convention based on the anti-clockwise also. It doesn't matter what you will consider, but if you are talking about sign convention along the clockwise direction, you have to stick to it. That means if I'm talking about my clockwise direction is positive, then obviously I have to consider my anti-clockwise movements or directions as negative. If I consider my anti-clockwise as positive, obviously I have to consider my clockwise movements or rotations as negative. It's kind of obvious, isn't it? If I am considering force on the right side is positive, obviously the force on the left side will be negative. So now let us say first consider that if I am assuming the clockwise movements or rotations are positive. So either you find the fixed end moments or you find out the rotations. If you're getting positive, then you will express it as a clockwise direction. If somehow you got it as a negative, then you will express it as a anti-clockwise direction. But the logic here is lies on the value of delta. Now let me tell you. Before that, can somebody tell me, imagine if there is a fixed beam and if the right side support, let us say AB, if B is sunk by an amount delta, can you guys tell me what about the fixed end moments that will generate at the ends? If the end B is sunk by an amount delta, what are the fixed end moments that will develop here? Have you guys noted it down or not? Fixed end moments. Have you guys noted down or not? If you guys doesn't note it down, then I will write down here. No issue.
There is it minus 6 EI del by L square.
Now see, imagine there are two ways. Imagine if the right end has sunk by an amount delta, and in the second case, let us say the point A has sunk by an amount delta. Now, imagine initially the beam is in horizontal direction, and can you tell me, as the right side sunk by an amount delta, in which direction the beam has rotated? Can I say somehow it has rotated in clockwise direction? By making some sense, it's not exactly clockwise because at support A there is no rotation, at support B there is no rotation, but still can I say that by visualization can I say that my beam AB is rotated in clockwise? Can I say it? Obviously if there is some rotation is happening in the clockwise direction, then what will be the resisting moment direction then? It will be opposite to it. So by visualization I can imagine that here Because as the right side support is sunk by an amount delta, by visualization I can understand that AB has rotated in clockwise direction. That means the resisting moment will always be in the opposite direction. What is the opposite direction? Anti-clockwise. One more important point you have to note it down is that the both ends the resisting moment will be same direction, either at A or at B. The resisting moment will be in the anti-clockwise direction and the magnitude will be 6EI delta by L square. So these are the fixed end moments that will develop in the beam if any one of the support has sunk by an amount delta. Similarly, can you understand in the second case? If the support is sunk by an amount delta, what do you think in which direction it might have rotated? Clockwise or anti-clockwise? Just imagine. Keep your pen on the initial orientation and try to take it on the deformed configuration and see in which direction it might have rotated.
Anti-clockwise.
Clockwise. Then what about the resisting moments? Clockwise direction. So here there is a clockwise moment will generated. What is it? 6EI delta by L square. And here also it will be clockwise. That is 6EI delta by L square. Right? Now, if you go back to the equation, what is our equation talking about? Moment at A towards B. What is the equation? Fixed end moment at A towards B plus 2EI by L times 2 times of near end rotation minus 3 delta by L minus 3 delta by L. Right? Now, what is the sign convention that we are taking? We are considering clockwise as positive, isn't it? If theta A is clockwise, we will consider it as positive. If theta B is clockwise, we will consider it as a positive. If fixed end moments are clockwise, we will consider it as a positive. Now, you can see here, if I multiply this to this term, how much I am getting? 2EI by L into 3 delta by L. Obviously, what I am getting? Minus 6EI delta by L square. If I am considering everything clockwise is positive, but what does this negative sign represents? What is the difference that with thinking of support? That means, according to the formulation, if everything is in clockwise direction, this 3 delta by L or the fixed end moment because of the delta, those are considered in the anti-clockwise direction. Anti-clockwise ACW. If, okay, let me clear for one case and then we'll go to the next case so that it might be clear. So now look at the first case and look at the second case. In first case, according to our sign convention, what about the fixed end moments direction? If B is sunk by an amount delta, 6A delta by L square, that in the anti-clockwise direction. What is our question actually? Our direction is, if it is clockwise, already we are considering it as positive. But if you see in the equation, there is some minus that is mounted here. That means, if we are talking about delta, this moment represents the anti-clockwise direction. Why I'm saying it is anti-clockwise direction? There is a negative sign here. That is what different from the sign convention that we have considered. So, if you look into the first case, it is making the anti-clockwise direction. As it is making the anti-clockwise direction, in the first case, you have to consider your delta as positive. Or if you talk about the second case, you can see here, in the second case, they are acting in the clockwise direction. But in the equation, we have considered it as a negative. So according to the equation, we have to consider the second case as negative. Why? Because substitute this value in the equation, what you will get? If you substitute delta as negative, what you will get here? This equation, 2 theta A plus theta B. If you replace delta with minus delta, how much you will get? You will get plus 6 delta by L square, sorry, plus 3 delta by L. Positive we have considered for clockwise direction. Is it represented our case or no? Is it confusing, the sign convention? Do you want?
Sir.
If it is confusing, let me know. We'll discuss one more time because it's there about sign convention only, nothing else.
Once again, please, sir.
Please.
Now, what we are talking about? Let me separate this equation. Fixed end moment plus, if you multiply, you will get 4A by L plus 4A by L into theta A plus 2EI by L into theta B minus 6EI delta by L square, right? What is the sign convention that we have considered? Either you can consider clockwise as positive or you can consider anti-clockwise positive, doesn't matter. Let us say if you are considering clockwise as positive, right? So you will find out the fixed end moment. If it is positive, clockwise you will take it as a positive. If it is anti-clockwise, you will represent it as a negative. Similarly with this thing also. Then what about this negative sign? What do you think here?
It represents anti-clockwise, sir.
According to our sign convention, clockwise is positive. But as it is negative, what does it represent? Anti-clockwise direction.
So to make it clockwise, we are adding a negative sign.
Yeah, that means if your delta, that means either right side support or left side support. If your delta is causing clockwise fixed end movements, that means just like here. If your delta, if left side support is sunk by an amount delta, these are making the clockwise movements. According to our sign convention, clockwise movement should be considered as positive. But you can see in the equation, according to our sign convention, it will be minus 6 plus 6A delta by L square. As in the equation already negative is mounted there. If delta is causing the clockwise movements, what do you have to take? You have to take delta as negative. Why? Because if you take delta as negative, then only they will become the positive, and that suits our sign convention. So if not positive or negative, what you can do is one thing. Whenever you want to represent this equation, negative or positive, you can do one thing. If they are making a clockwise movement, you treat them as a negative. If they are making an anti-clockwise, treat them as. So whenever you are writing the equation, you write it down, fixed end moment AB plus 2EI by L times 2 times of near end rotation plus far end rotation. First forget about the sign, 3 delta by L. Now, if support B sunk by an amount delta, fixed end moments will develop in which direction?
Anti-clockwise.
In this case, fixed end moment will develop in anti-clockwise direction. According to our sign convention, if they're anti-clockwise, what do you have to consider?
Negative.
Negative. Forget about delta is positive or negative. We just directly place the negative value here. If support A is sunk by an amount delta, in which direction fixed end moments will develop in this case?
Clockwise.
Clockwise. So what you should do? You'll do only one thing, fixed end moments AB plus 2EI by L times 2 theta A plus theta B plus 3 delta by L. I think it will be much more clear. Instead of you taking delta as positive or negative, don't write down the sign first of all. What you will do is that see the sunking at what support the sunk is happening, sinking of support is happening. Then according to that, you identify the fixed end moment direction, and based on the direction, you represent whether this negative or the positive will come into the picture. Now is it clear?
Yes, sir.
But in the exam, if they ask you like in state PSU's exam, if they ask you the fixed and moment equation, slope deflection method, then usually the formulas are represented with -3 delta by L. So don't always think about, don't select the option which is having positive. In general, we'll represent with -3 delta by L. Okay. I think we have already seen what are the, after writing this equation, what we should do. We have to apply the equilibrium equations, and then we have to find out the unknowns. That's it. After that, we have to solve the remaining problem. So for that, let us solve a simple case. First of all, let us talk about very much simpler case, and then we'll take it deep. Let us say 10 kilonewton, 2 meters, 2 meters, 4 meters, and 5 kilonewton per meter. First of all, can you tell me what is the kinematic indeterminacy? What is the static indeterminacy in this case? What is the kinematic indeterminacy? These things you should not take much longer time. Kinematic, why only Vishnu has responded? What about others? Ramya, Pirashni. So here the kinematic indeterminacy is 1, that is rotation at B. Can you tell me what is the static indeterminacy here?
3, sir.
3. Okay. Now, so which one is easier to solve? By taking kinematic indeterminacy or by taking static indeterminacy?
Kinematic indeterminacy.
Kinematic indeterminacy, right? Now, for that, let us say that slope deflection method. How come the static indeterminacy is 5, Vishnu? Yeah, how come it's 4, 3? If I neglect the axial deformations, what do you think? How many will come into picture? Let us say I have neglected the axial kind of thing. Why? Because in being generally that's what we'll do. Here, how many will develop? Vertical, rotation, vertical, vertical rotation, total 5 minus, as I already ignored axial, 5 minus 2, 3. Now, what is the kinematic indeterminacy? 1. That is, number of unknown is 1. That means how many equations we have required? 1 equation, right? What is that equation? At joint B, as you can see, summation of moments at joint B should be equal to 0. At joint B, how many moments will exist? 2 members are connected. What are they? Moment at B towards A plus moment at B towards C, that can be equal to 0. Right? Now, before moving on to write down the things, let us find out the fixed end moments. What is the fixed end moment at A towards B? Loaded center. What is the fixed end moment?
L by 8, sir.
WL by 8.
8.
That will be equal to how much it will be? Clockwise or anti-clockwise?
Is it anti-clockwise, sir?
Okay, it will be anti-clockwise. According to our science, anti-clockwise is negative. So minus load 10. What is the length? 4 divided by 8. I think this calculation we can find it out easily. Similarly, what is the fixed end moment at B towards A? Same, WL by 8, but it will be in the clockwise direction. As it in the clockwise direction, positive. That will be equal to 10 into again 4 by 8. That will be equal to plus 5 kilonewton meter. I think you guys don't have any doubt in fixed end moments. If you have doubt, let me know about the direction. What are the fixed end moments in the member BC? UDL load is acting in the span BC. What is the fixed end moment?
WL square by 12, sir.
Total at NB it will be anti-clockwise. So minus WL square by 12. That will be equal to minus 5. Length given as 4. 1 by 12. How much it will be?
Minus 6.66.
Yeah, minus 6.67, let us say. Similarly, what is the fixed end moment at C towards B? it will be opposite direction plus again.
Yes, WL square by 12, so plus 6.6.
As I need only one equation, I'll just write down directly this. Is there any sinking of support that I have given in this case? No, right? As there is no sinking of support, delta is equal to 0 everywhere. So there is no need of considering delta. That is directly 0. Now, what about my fixed end moment at B towards A? That will be equal to, what is my fixed end moment at B towards A plus 2EI by L times 2 times of what is my near end rotation? Theta B plus theta A minus delta by L. In our case, delta is equal to 0. What about rotation at A? As it is a fixed support, what is the rotation at A? 0. Again at C, as it is a fixed support, the rotation is 0. Now quickly tell me, what is my fixed end moment at B towards A? 5. Let us assume that
Okay.
EA is constant. What is the length of the span AB? BA 4 times
4.
theta B is the unknown. Theta B. What is the rotation at A? 0, right?
0.
As it is a fixed support. So it is just simply 5 plus EA times theta B. Similarly, what is the final end moment at B towards C? That will be equal to, again, fixed end moment at B towards C plus 2EI by L times 2 times of near end rotation theta B plus far end rotation theta C minus 3 delta by L. As even in the BC, there is no sinking of support, delta is 0. What is the fixed end moment at B towards C?
Minus 6.6.
Minus 6.67 plus, again, 2EI by length given as 4. 2 times theta B is unknown. What is the rotation at C? As it is a support, 0. So that's I'm not writing simply. Again, how much it will be? Minus 6.67 plus EA times theta B. Now we have only one equation. Summation of moment at B is 0. That implies what we can say? Moment at B towards A plus moment at B towards C, that will be equal to 0. So how much will get? Add these two equations. 5 plus EI theta B plus minus 6.67 plus EI theta B will be equal to 0. Can you quickly tell me what is the rotation at B then? As we are discussing, that's why I'm forcibly writing these equations. But instead, if I directly know all these things, directly I can simply write down this equation. And directly I can write down this equation, and directly I can write down this. So it won't take not more than 1 minute if this problem is given. So that's why we should not expect that every problem is not a lengthiest problem. At least if we know the procedure, then we can solve any kind of thing. Quickly, can you tell me how much you are getting? What is the rotation at B? Do not take too much time on calculations part, as these are much easier. Minus 1.67 positive by 2.835, as it will be 0.835 divided by EI. Clear? If you want to solve the same problem by force method, we have to solve how many equations? 3 equations, and we have to generate 3 equations. Then only we will be able to solve the other unknowns. But instead, as kinematic indefiniteness is less here, we have quickly solved. So quickly, can you guys find out what is the MAB, MBA, MBC, MCB? So quickly tell me the equation. MAB is nothing but a fixed end moment at A towards B. What is the fixed end moment at A towards B? For our case,
Minus
minus 5 plus 2EI by length is given as 4 times 2 times of near end rotation. What is the near end for this? A. What is the rotation at A? 0. less what is the rotation at B?
Theta B.
Are we getting positive rotation or negative rotation? Positive. What is the sign convention that we have considered? Clockwise is positive. That means as theta B is positive, rotation at B is happening in the clockwise direction. So plus what is the rotation? 0.835 by EI. There is no need of considering delta as it is equal to 0. So quickly tell me how much you are getting. How much you are getting? Guys, calculation part you guys have to do it. If you are not interested, then I just minus 4.58. Similarly, at B towards A, what is the friction moment at B towards A? Plus 5 plus 2EI by what is the length of the beam? 4. 2 times of what is the near end here? Theta B. What is the theta B value? 0.835 by EI plus or plus far end rotation A. What is the far end rotation? 0. Similarly, tell me how much you are getting.
Then 5.835.
5.83 kilonewton meter. Similarly, MBC. What is the fixed end moment at B towards C? According to us, it is minus 6.67 plus 2EI by length of the beam is given as 4 times 2 times of what is the near end rotation? B. So 0.835 by EI. Again, what is the far end rotation? Theta C? 0. How much you are getting? Yeah, minus 5.80. So this was the one cross verify. As you can see, if you add these two, you should get it as 0. That's what the kind of calculation mistake that you guys can verify. If these are not coming as 0, then you guys have to think of where you guys have committed wrong. Similarly, what about MCB? Fixed end moment at C to B plus 2EI by what is the length? 4 times what is the near end? Theta C? 0. What is the far end? 0.835 by E. Quickly tell me how much you are getting. 6.87 kilonewton meter. Why you guys all are short from your pre-reasoning? What happened to you? Are you guys doing or not?
Calculating, sir. Yes, sir.
Yes, sir.
Fine, then let's come back here. So after finding the final line moments, what we have discussed that we have to find out the remaining unknowns. What are the remaining unknowns? That might be support reaction, that might be shear force diagram, and that might be bending moment diagram. Right now, for that, let us separate this beam. So this is what the span AB. This is what the span BC. Now, what is the final line moment that you have got at A towards B? Minus 4.58. Minus represents anti-clockwise. So I am representing the anti-clockwise direction, 4.58. And at B towards A, 5.83. It is clockwise, 5.83. Similarly, here it will be anti-clockwise, 5.83. Similarly, at NC, 6.87 positive. That means here it is clockwise. Now let us represent the external applied load also. Here this we have considered as a 10 kilonewton, 2 meters, and here the UDL is considered as 5 kilonewton per meter. Now, let us find out the support reactions. Now, for finding the support reactions, what you can do, you can split the forces and then find it out. That means, now imagine only 10 kilonewton force is there. What about the reaction at A and B? Can you tell me? At B. Is it clear my question? In this beam,
You are
AB
asking
now,
the reaction?
now see, now we have, after the split out, what you have to do? You have to find out the reactions here, you have to find out the reactions, and you have to find out the reactions, right? So instead of taking the entire beam, we have split AB, BC. Why? Because we have already found the final line moment set in the individual spans. So we have drawn the free body diagram of individual spans AB and BC. Now we have to find out the support reactions at A, at B, and at C. So that's what we are doing now. So for finding the reactions here, you need to consider this, you need to consider this, and you need to consider this. So instead of considering everything at a time, I'm asking you to consider differently. What if 10 kilonewton is only acting? What might be the reaction that's generated at A and B?
5, sir.
5 and 5, right? Why? Because it is exactly at the center.
Center.
5 and 5. This is because of which one? 10 kilonewton, right?
Yes.
Now, forget about the load and look at the moments only. 4.58 and 5.83. Now forget about 10 kilonewton. What might be the support reactions? Let me draw it here. There is an anti-clockwise and there is a clockwise. 4.58, 5.8. Now look at these two values. 4.88 is trying to rotate in anti-clockwise. 5.83 is trying to rotate in clockwise. So what will be the net moment direction here? 4.58 in anti-clockwise, 5.83 clockwise. If you add these two, what?
1.3.
Direction, clockwise direction, isn't it?
Yes, sir. Clockwise, sir.
If you want to restrict the clockwise direction, what might be the support reactions? They should act in anti-clockwise direction. For anti-clockwise, if this reaction is downward, if this reaction is upward, then only they will make the anti-clockwise direction. Now, what about that magnitude? This thing I think we have already discussed. If the beam is trying to rotate in clockwise, the reactions will act in anti-clockwise direction. So here, instead of one moment, there are two different moments. That's what you will do. Sum those two values. 4.58 in anti-clockwise, 5.83 in clockwise. What is the net value you will get?
1.3.
3 minus 4.58 divided by, sorry, that will be equal to how much?
0.25.
3 then.
If you subtract, is saying that 1.25 will get, and the reactions will be 1.25 divided by length of the beam, 4. 1.25 divided by 4. So 1.25 divided by 4.
0.3.
0.312. So this is 0.31. This is 0.31. Because of the 10 5 in direction, because of the moment, the reaction will develop here is 0.31 and here it is upward 0.31. What is the net value then? Because of both 10 kilonewton and because of the moments, what we have to do? We have to add these forces. Because of 10, 5 is in upward. Because of moments, 0.31 in downward. What is the net value?
4.69.
So
Upward,
4.69, that will be in the upward direction. 4.69. What about here? Both are in upward direction.
Yes, sir. 5.31.
5.31. As it is only point load, if you even use summation of moments at any point equal to 0, you might get the answers easily. But this is also one way of solving the unknown reaction. Now it might complicate it, but when you practice, you will directly do it without much effort. Similarly, because of here, can you do it in the same way? Because of the UDL only, what about the reactions? Because of only the UDL, what about the reactions? There is a load, 5 kilonewton per meter, span is 4. What about the reaction develop here and what about the reaction develop here? Again, they are
10,
similar.
sir.
Total load by 2. What is the total load? 5 into 4, 20 by 2, 10. So because of the UDL, whatever the reactions, upward 10 and upward 10. Now look at the moments. Left side it is 5.83 anti-clockwise, right side 6.83 clockwise. So what is the net value? 6.83 minus 5.83,
One,
it is
sir.
nearly 1. That is in trying to rotate your beam in
1
clockwise direction.
clockwise.
That means your support reaction should be in anti-clockwise direction. For anti-clockwise, this should be downward, this should be upward. So what is the magnitude? What is the net moment direction? 1 divided by total length 4, that will be equal to 0.5, 0.25. What about the net reaction here? 10 is in upward, 0.25 in downward. What is the net value? 9.75.
9.75
0.25 in upward. What is the net value? 10.2. Any doubt in
10.22.
any doubt in support reactions?
Clear, sir.
No. Now let us represent the forces in the original diagram. Now here at A, what is the support reaction that we have got generated? At A, what is the reaction that, what is the net value? 4.69. What about the reaction at B that is generated? At B, how many? We have two spans, right? This one we have
Yes,
to
sir.
here, and this one we have to here. So how much it will be? 5.31 on the AB, 9.75 on the BC. Then what is the net value?
15.06.
0.06.
15.06. And here at C, only one, that is 10.2.
10.25.
Add all these values and tell me how much you are getting. Add these three support reactions.
30, sir.
30, exactly 30.
Yes, sir.
And
Yes,
see
sir.
the total downward force. So what is the total downward force? 10 on the AB, 5 into 4, 20, 20 on the BC. So total is
30.
30. Are they balancing?
Yes, sir.
That means our
Yes, sir.
calculations are right. Similarly at A, what
Yes,
is the
sir.
end moment? Similarly at A, what is the end moment that we have
4.58.
spent? 4.58. And then at C, it is clockwise, 6.8. Right? Now, so what is the reaction that we have generated at A? Can you quickly tell me? 4.69. And at B, how much you have got? 15.06. And at C, how much you have got?
10.25.
And here the moment is anti-clockwise, 4.83. Seems 4.58. Here the moment will be 6.83. And there is a downward load, 10 kilonewton. And also there will be UDL load here, 5 kilonewton per meter. Let us draw the shear force and bending moment diagram. Now, what is the sign convention that we follow for shear force diagram? Right side upward,
Right side
90.
upward negative.
Now, look at it C and look at in the right side direction. And how many forces can you see? Let's see if you look into the right side direction, how many forces you will see? Only one, that is 10.25. We are looking on the right side and the force is in upward direction. That means it is a negative shear force. So the negative shear force that I have represented in downward, 9.25. And look at it B. As there is a UDL force here, how the shear force will vary? If there is a
Yeah.
UDL on the beam, the shear force will vary linearly, constant, or parabolic.
Constant, sir.
If there is a UDL on the beam, the shear force will vary linearly or parabolically or constant.
Parabolically.
SFD and BMD is done right in strength of materials.
Yes, sir.
That
It varies constantly, sir, not parabolic.
load, shear force diagram, bending moment diagram. If the load is constant, increase 1 degree. Or if the load is not constant, if the load is concentrated, your shear force diagram is constant. Constant means what is the power?
Sir.
Let's say
Slope will be 0, sir.
what is the slope will be equal to 0, or you can say x to the power 0. Your bending moment will be linear. X to the power 1. Add 1
Linear.
more.
1.
If the
Yes, sir.
force is UDL, if force is UDL, what is the power? X to the power 0. You
1,
add one
sir.
more degree. That
Yes,
means
sir.
your
Yes, sir.
force will vary linear. That means x to the power 1.
Linear.
Whatever your bending
X
moment,
power 1.
add one more degree for bending moment.
Parabolic.
Parabolic. If your load is uniformly
Power 2.
varying load, what is the degree? X to the power 1. You add one more degree.
1.
That
1.
means your shear force will vary parabolic to the power 2. Whatever
Parabolic.
bending moment,
X
that will be in the form of cubically.
cubic parabola.
So depending upon the load, you have to add one more degree. That's what you will get the shear force diagram and bending force diagram. As UDL is here, for shear force diagram, add one more degree, that will be linear. So very just nearer to the point B, just to the right of point B. Why I'm saying as at B, as it is a concentrated, we cannot define. We'll say just to the right of B. What is the shear force? Look at the right side and tell me. 10 is in upward. At this point, 10 is in upward according to our sign convention, minus 10.25. Then what about this load? Total UDL is how much? 5 into 4. Total 20. As it is in the downward direction, plus 20. If we add the value, how much you will get it? 9.75.
7.
I don't know how much you guys are equipped with just before this class. So here the point is positive. It will be 9.75. So in between these two vary linearly and joined by linear line. Now similarly consider just to the left of support. And if you look into the right side direction, how much you will get it? What is the difference you will see there? I don't know whether you guys understood or not. If there is support reaction in between 15.75, what you should do? You have to consider a point just to the right of support, and one more point you have to take left to the support. So if you are taking just to the right side, this 15.75 will not come into the picture. But if you take this point and if you look into the right side, this 15.75 will also come into the picture. That is what the difference that we will be there at the intermediate support. So if you look at just to the left and if you look into the right side, already we have got 9.75. In addition to that, how much we got here? 15.06. So add 15.06. How much you will get it? 0.75 plus 15.06. Let me ask you one more time. Can I discuss this one more time, this diagram? Or are you guys are okay with whatever you got learned in strength of materials?
Sir, we'll go through with our procedure once, sir, and then we'll let you know, sir.
Your procedure, which procedure that? Can you please somebody tell me what is your procedure?
No, sir. Actually, we used the slope method to draw the shear force and bending moment diagram, sir.
How?
Slope method, sir.
Can you please explain me here once? Which one is more difficult, this one or the previous one?
No, slope method was a bit easier for us, sir.
How? I don't know. I just want to know how you guys learned it, so that I can explain something there. Anyone of you can explain and we can discuss here.
1 minute.
Yeah, fine. Why? Because if you are comfortable with that and you got the right answer, then from now onwards, I'll take an example of that only. Instead, there is one shortcut. Now forget about this. As of now, is it clear? 9.75.
Yes, sir.
Now forgot about at this joint. Now come to the support A. At support A, can you tell me what is the shear force? If right side upward is negative, left side upward is positive. So what is the shear force at A? If you look into the left side,
4.69.
Force is an upward. So positive. How much it will be? 4.69. Let us say this point is E. In between E to A to E, is there any load?
No load, sir.
No. As there is no load, it will be constant, right? So let us assume it will be constant.
Constant.
And then at E, there is a sudden decrease in load. Then what is the shear force at point E then? Let me tell you. Let me explain one case. Okay. Now, as I'm telling you, wherever there is a concentrated force, wherever there are reactions, we cannot define the shear force at that point, isn't it? That's what we have discussed.
Yes, sir.
Now, look at point C. Can we define the shear force at point C?
No, sir.
No. In that case, what we should do? We have to take a section immediate to the left or immediate to the right. Let us say,
Right.
is there
Yes.
any span beyond the C? No, right?
No,
So that's
no,
what
sir.
I'm doing. I'm just considering a point immediate to the left of C. And I'm talking, this is my section. Look at your right side. How many forces you can see?
1.
1. That is how much?
20.
Downward, right? According to our sign convention, right side upward is negative.
Negative.
Right side, force is downward, so it will be positive
Positive.
20 kilo. In between B to C, is there any load?
No load, sir.
No, right? So that's why in between B to C, constant,
Constant.
right? Again, tell me, can you define the shear force at point B?
No, sir.
Again, what you should do, if you cannot define, you have to consider a point just to the right side of it and just to the
Left side.
left side of it. And I have considered, even though there are some distance, imagine that they are negligibly small. Just for your understanding, so I'm representing there. So
Yes,
this
sir.
is your section imagine, and this is your section imagine. Now the point is, now if you look into the right side at this section, how many forces you can see?
1.
That is 20 kilonewton.
20 kilo.
If
Downward.
you look at this section and look into the right side, how many forces you can see?
2 forces.
What are they? 20 and 10.
10.
So this is what the difference. Wherever you are encountering with a point load, what you should do is that take 2 points just to the right side and just to the left side and see in one direction and see how many forces are acting. Literally speaking, my point is to say that out of those 2 points, just like here, at this point, 10 kilonewton will not come, but at this point, 10 kilonewton will encounter. So let us say this is B to the right, BR. This is B to the left, BN. Now, at BR, what is the shear force? Can you tell me?
10, sir.
At BR point, if you look into the right side, what is the shear force?
20
Look into the
right side.
only one force, how much? 20. What is the shear force then?
Yes, sir.
What is the shear force?
20, sir.
Sorry, could not hear you.
To the right of B, it is 20, sir.
To the right of B, it is 20, right? So it is 20. Now
Yes,
come
sir.
to the BL and look into the right side. How many forces you can see?
2 forces, sir.
What are
20
they?
downward, 10 upwards.
Because of 20, positive shear force, plus 20. Because of 10, it is an upward. According to our sign convention, it will be negative. What is
Negative.
the net value?
10, positive 10.
Positive. So just to the left, 10. So we should do, there is a change here. This is how you should
Yes.
draw. Even though at this point it is 20, at this point and you cannot draw like this. As these 2 points very, very close, you have to represent with vertical line only.
Okay, sir.
Now is it okay? How to find a
Yes.
shear force at intermediate support?
Yes, sir.
Now come back to here. Can we define the shear force at point E? Can we define the shear force at point E? Can we define the shear force at point
No,
E?
no, 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 sir. No, sir. No, sir.
Why? Because there is a concentrated force. In that case, what we should do? We have to take a section I to the left as well as
Left.
to the right.
Right.
Now, to the left of E, what is the shear force? Look into the left side.
0.69.
4.69
4.69 positive,
upwards.
Positive, sir.
right? Now, to the right of E, look into the left side. How many forces are there?
2 forces, sir.
Now, what is the net value? Because of 4.69, positive shear force, 4.69. Because of 10,
Minus 10.
minus 10. How much it will be?
Minus, sir.
Minus
Minus 5.31.
5.31. So just to the right, what is the value? Minus 5.31. And then join these two by vertical line. Clear?
Yes, sir.
Now, in between E to B, that means E to B, that means in between here. Is there any load?
No load, sir.
As there is no load, what is the shear force? Constant.
Constant.
And then join these two lines. See the change here? What is this change? Can you tell me? What is the total change in ordinates? TNPSC?
8.06.
Are we getting the reaction at that support? Now similarly, see
Yes,
the
sir.
change here. Minus 5.31 plus 4.6. Now are we getting the change here? So if you are having only two spans, then you can come from right side and you can come from left side and then you can fix the diagram too. Nothing wrong from here. How you guys can learn, I don't know. Can somebody please tell me? I'll just see which one is easy and then I'll continue.
This is okay, sir.
This is okay? Fine?
Yes, sir. Fine, sir.
Okay, then let us draw the bending moment diagram. So for drawing bending moment diagram, what we will do is that we will superimpose two things, just like the forces. Reactions, how we have found out due to reaction and then due to end moments. So here we should draw bending moment due to final end moments and then bending moment due to applied forces as simply supported B. Again, we are writing this diagram. Can you quickly tell me here this I have remembered 15.06. Here it is around 4.58 and here it is somewhere around 6.83. Let me know if they are wrong values. 4.69, 4.5, 4.5, 4.6, 6.83. Right now, see the span AB. What is the sign convention for bending? What is the sign convention for bending moment?
Sir, the reaction value at C point is 10.25 now,
Yes,
sir.
sir. 10.25, sir.
Thank you. Can you tell me what is the sign convention for bending moment diagram?
Outside anti-clockwise positive,
Sorry.
right side anti-positive.
I don't know if somebody asks the sign convention, then you have to say if it is sagging bending moment, it will be positive.
Positive.
If it is hogging,
Hogging means negative.
right? Sagging means tension at the bottom. Hogging means tension at the top.
Tension.
Now, what is the final end moment at A? It is 4.58.
2.58.
Imagine that in your hand you are having a book. At left hand your support A and at right hand your support B. At left hand A, try to apply the anti-clockwise movement. And can you imagine where you are getting tension and where you are getting compression? Once more I'm saying, imagine that there is some book at your hand. Imagine left hand your A, right hand your B. At hand A, try to apply and can tell me where you will get tension. Upward fibers or bottom fibers?
Bottom, sir.
Tension
Top fibers tension, sir.
Fibers tension. If top fibers are tension, it will be counted as hogging, negative. So, at A, what is the bending moment diagram? Instead, let me do one thing. I don't present the yet. So, what is the bending moment here? As it is a hogging negative, I am representing in the downward direction. What is this value? 4.58. Now, at B towards A, what is the moment? It is clockwise 5.8. Again, the same thing. Imagine there is a book in your side. Apply the clockwise moment on the right side point, and imagine where you will get the tension.
The top fiber, sir.
Again, top fibers. Again,
Hogging.
this tension. So, what is the magnitude there? 5.8. When at B towards C, what is the moment? Anti-clockwise 5.83. Even if you apply the same moment, you will get tension at the top. Now, similarly, look at joint C. What is the moment you will get? 6.83. Imagine there is a span BC. Apply the clockwise moment on the right side. Which moment you will get again? Imagine there is a beam BC. B is at your left hand support. C is on your right hand support. At right hand support, try to apply the clockwise moment, and where you will get the tension, to the top or to the bottom.
Top fiber, sir.
Top, sir.
That means again here also it will be same
Hogging.
thing. How much it will be? 6.8. Right? Now join these lines by a straight line. Okay. So this is what the bending moment diagram due to fixed final end movements. Right? Now, here we have not considered any point loads, right? Now, after that, what you should do? Consider simply supported beam representing the applied load. So this is what the applied load, 2 meter, 2 meter. Imagine this is your center point. Can you tell me what is the bending moment at the center? Simply supported beam, there is a central point load. What will be the bending moment at the center? What taking you so much time?
WL by 4, sir.
WL by 4, right? 10 kilonewton meter. Hogging or sagging moment at center?
Sagging, sir.
Sagging, right? So what is the shape of it? Isn't it? So what is this magnitude? 10. Is it right? Correct bending moment diagram, or I have represented it wrongly? What will
Sagging
the-
means curve should be
Sag-
downwards.
Sagging, positive. I'm talking about the shape. If there is
Okay,
a
okay,
point,
sir. Yes, sir. Yes, sir.
if there
It
is
is
a point,
a
yeah,
triangle, sir.
yeah, triangle.
It will
That's
linear.
right.
Linear,
Triangle.
linear.
Now in the span BC, what is the UDL? Ring is UDL. What about the shape of the bending moment?
Parabolic.
If it is a
Parabola, sir.
so simply supported, subjected to this UDL loading. What is the bending moment? Maximum bending moment?
WL square by 8.
8. So as it is UDL, maximum we will get at the center again. So this is what the maximum value. So can you tell me how much you are getting this value? What is the value of WL square by 8?
5, sir.
5.
10.
5 into 4 into 4 by 8.
4.
How much?
Okay, okay, sir. 4.
10, right? Again? No.
Yes, sir. Yes, sir. 10, sir.
So this is everything, it is positive, and the bottom line everything is negative.
Negative.
So generally what happens is that in bending moment diagram, what is the, at any point find out what is the bending moment value. That means you have to add these two values. Bending moment due to final moments, and then bending moment due to simply supported beam. That is what your bending moment value at any point. Generally, we have represented in the downward direction, but these values, they will be represented in the upward direction only. Here it is 4.58, here it is somewhere around 5, and here it is somewhere 6.8. Now you can see this portion, or you can see this portion, let us say. Now, you can see this portion. This is entirely covered by which one? Whatever the shaded portion that I have drawn, this is suppressed by positive values or not?
Yes, sir.
Till this region. That means from here to here, which are having the more values. Positive values are dominated by negative values. So from this, we are in movement. But what about this area? Here, this area. Which values are dominated in this
Negative
area?
is more.
Negative values are dominated in
Negative.
this area. So that's why from here to here, negative bending moment. So when you look at this value, from here to here, which are dominated? Positive is dominated.
Positive.
Similarly, in this portion,
Negative is dominating.
that means if you are taking this portion, where you have to provide the steel reinforcement, where you are getting the tension, at the top fibers or bottom fibers?
Top fibers, sir.
Provide the reinforcement, isn't it? In this portion, you will provide the reinforcement at the top. What about in this portion, where you are getting the tension? Getting the tension at the bottom. That means where you have to provide the reinforcement in this span, bottom. Similarly, in this span, you have to provide the reinforcement at the bottom, and in this span, you have to provide the reinforcement at the top, and whatever this gap here also you have to provide the reinforcement at the top. So this is all general common interview questions, like they will ask you to draw the bending moment diagram, and based on the bending moment direction, you have to identify where the steel will be mounted. I don't know whether you guys have visited any construction site. If you guys have visited there, you might see that wherever there are joints, additional reinforcements are provided at the top. Why? Because wherever there are joints, usually the tension will be occur at the top fibers at the joint locations. That's why additional reinforcements are provided at the joints at the top. Clear? Any doubt in this diagram?
Clear, sir.
Shear force diagram and bending moment diagram and support reactions.
Yes, sir. Clear, sir.
When we are talking about the moment distribution method, only the difference from this method is that final end moments only. After we found the final end moments, then next we'll find the support reactions, and then we'll draw the shear force diagram, and then we'll draw the bending moment diagram. Same thing. The procedure is same after we find the final end moments. So that's why we have clearly explained this program. But in the next class, or when moment distribution method is discussed, these things we won't discuss again. How to draw shear force diagram and bending moment diagram. Okay. So if you have any doubts, let me know, or else I'll just ask you to solve one simple example. If you want to solve this by using slope deflection method, can you tell me how many unknowns you have to consider? How many unknowns we have to consider? Am I audible?
Yes, sir. Unknowns in the sense you are asking.
Kinematic indeterminacy. If I'm talking about static indeterminacy, that's the kinematic indeterminacy are our unknowns.
Okay, sir.
So what are those unknowns? Can you quickly find it out? One thing I am sure that rotation at A, rotation at B, and rotation at C. What about at point D? We will have ambiguity at this portion only. At the end of the day, what we are finding? Final end moments, isn't it?
Yes, sir.
Now, if you look into the portion BD, is it a determinate portion or indeterminate portion? That means If I take any section, can I find shear force, bending moment? If I cut a section like this at a distance of 1 meter from D, can you tell me what is the shear force?
When, sir?
Yeah, looking to the right side. 10.
When, sir?
And what about the bending moment? Now
10
here I'm not
into
worried
1,
about the
1.
side.
That is
10
also
into
10,
1,
sir.
10, right? That means BD is a determinate portion. If it's a determinate portion, then no need to find it out. So instead, what I will do, A, B, C. Can you tell me whatever the reactions will generate here at this joint? If I separate this BD from the remaining part, what about the reactions that will generate here? Here, how many reactions will develop? Downward force is 10 kilonewton. How to balance it? Upward
What
force
one?
10 kilonewton. And then these two are trying to rotate your beam in which direction? BD needs. Clockwise.
Clockwise.
How you will balance it? Anti-clockwise movements. And what is that value? Total distance is 2 meters. Then how much it will be? 10 into 2, 20.
20.
That means what is the moment at B towards D? How much it will be? How to represent this moment? This is what moment at B towards the side D. So that's why moment at B towards D. How much it will be? 20. According to our
20,
sign
sir.
convention, it is in anti-clockwise direction. As it is in anti-clockwise direction, minus 20 kilonewton meter. So that's why wherever there is a overhanging part, there we should not consider the unknowns. So total how many unknowns you have to consider if you want to solve this by slope deflection method?
3.
3 unknowns, right? Now, again the same thing. You will express MAB, you will write down MBA, you will write it down MBC, you will write down MCB. What about MBD? These 4 expression, what you will do? You will write in terms of the slope deflection equations. But what about MBD? As it is a cantilever part, we have already known that value. What is this value? Minus 20 kilonewton meter. What about these 4 values? As we don't know, we are expressing this in terms of the slope deflection equation. So how many unknowns are there now? 3 unknowns, right? So for those 3 unknowns, can you tell me what are the equilibrium equations that you have to consider?
3 equations.
Identify the 3 equations. What are the equations? As it is a hinged support A, moment at A should be 0. Hinge at C, moment at C should be equal to 0. At support B, as it is a rigid support, then summation of moments at support B should be equal to 0. While expressing this, what we will write it down? We will say at B, how many members are connected?
3 members.
3 members, MBA plus MBC plus MCD will be equal to 0. Only the difference, sorry, MBA, MBC, MBD. Only the difference that makes here is MBD. MBD value we can directly replace it with by minus 20. No need to represent it by using the slope deflection equations. Now can you find out or can you solve this problem? Is it okay this problem or any other doubt in this problem?
We will try, sir.
At least whatever we have written, one point you have to understand is that BD is a overhanging part. You should not consider the unknowns there. Why? Because BD becomes a determinate part. We can find out the moment at B towards T that we have seen directly that we are getting it as 20. So wherever there is a determinate portion, there no need to consider the unknowns in form of displacement. That means at point D, we will not consider theta D or deflection at D. That means in the portion BD, we will not write the slope deflection equations. One value that is moment at B towards D, we will obtain. And remaining, we have to write down slope deflection equation and then we have to solve it as it is. After finding fine line moment, find the support reactions, draw the free body diagram each time, find out the equilibrium equations and solve the unknown support reactions, and solve the shear force diagram and bending moment diagram. The same kind of thing. Is it okay, the procedure, how we want to proceed it?
Yes, sir.
So what we can do, you can try this problem, and then guys, wherever you start, we'll discuss in the next class, and then we'll start the moment distribution method. Is it okay?
Yes, sir.
Okay, if you have any queries, let me know, or else we can stop here.
Nothing, sir.